Hey everyone, Chang here and welcome to my channel. This is the Bare Minimum Algebra series, and today we're going to be focusing on adding and subtracting exponent. Now, you can think of this as a subset of combining like terms. Combining like terms have all these different criterias of when you can or when you cannot combine them. This one is a subset of it. But it's very important to actually emphasize the requirements for when and when you cannot add and subtract exponents. The key is fairly simple. Both the base and the exponent itself must be the same before you could even do anything. Base, exponent must be the same. It cannot be kind of close. It cannot be same exponent and not the same base, or same base and not the same exponent, or it looks similar, they are very closely related. None of that. If they're not exactly the same, you really can't do anything with it, right? If they are squared, if it's x squared, the other one has to be x squared as well. If it is cube, it has to be cube. If it's to the 1/4 power, it has to be to the 1/4 power. If the base is 7, it cannot be 8. Cannot be 6, cannot be 1/7, it has to be 7, right? I can't emphasize this enough because it gets confusing, tremendously confusing, when all of a sudden numbers are flip-flop and they think, oh, well, they're fairly close and I'm going to combine it somehow. It doesn't work that way. So if you can guarantee that the base and the exponent of the different expression that you're trying to add and subtract are exactly the same, then it's fairly simple, because all you have to do is go through one single step. Add / subtract the coefficient. Basically the number in front of the variable or the number in front of the exponent expression, right? That's all it is. Now, if there is no number in front of usually the variable more than anything, maybe sometimes the exponent expression, depends on how the problem's written, I'm a little iffy about that, then imagine an invisible one. There's many cases where you have to imagine an invisible one. This is one of those cases. So instead of me just rambling on and on and on and on, let's go over some examples. All right, let's go over these two examples fairly quickly. Okay, once again, check. Base, exponent, the same, yes. Base, exponent, the same, yes. Now, don't take this too far. The coefficient can be different. That's entirely fine, right? If the base and the exponents are the same and all the things that we are adding, subtracting, you can subtract as well, right? I just decided to do adding, subtract, same thing. What you're going to do is you're going to either add or subtract the coefficient. In this case, the coefficients are 2 and 5. So therefore, the final answer would just be 7, and the exponent expression is still the same. Okay? Now, this is a case where there is an invisible one. Hopefully you guys can see that. The exponent expression is this guy inside here. 5 squared. Now, I wouldn't normally combine it and then just start multiplying. It's kind of weird, but I guess some people will like it, and this can be a situation where you will see invisible one. So, here it is. This is a 3. There is technically an invisible 1, if you want to think of it that way. And then what you're going to do is the same thing. You combine the coefficient, it's going to be 4 times the expression is going to be 5 squared, which is basically 4 times 5 times 5, or 4 times 25, which is 100. Okay? Plain and simple. So that's how you would go about adding and subtracting. Now, subtracting, if I change this all to minus sign, the coefficient, you would just subtract. 2 minus 5 if it was a subtraction, and 3 minus 1 if it was subtraction. Plain and simple on that. All right, so let's look at some examples, and I want you guys to really focus and see which one you're allowed to actually solve, evaluate, combine, and which one you're not. Let's look at these two examples. Lovely examples. I love them. First one, fairly simple. You can solve it. You cannot combine it, but you can solve it. Right? The reason I say that is because that's one of those, be very careful of the way they word the problem. You can expand all these guys out, combine it, simplify it, yada, 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 and eventually get an actual number, right? Because this one is going to be what? 16, 5 times 16 plus 5 times 8, and then add them together and you get a solid answer. So you can actually solve this, but you cannot combine it. The reason you cannot combine it is fairly simple. Remember, there are two criteria. Base and exponent must be the same. Base is the same, wonderful. Exponents are different, not so good. Doesn't matter that the coefficient is the same. It makes no difference, right? The base and exponent must be the same. If this happens to be a 4 or this happens to be a 3, then it's lovely, right? Then you have 10 times 2 to the third power or 2 to the fourth power, depending on how the number was changed, right? Then you can solve it. But outside of this, you can solve it, but you cannot combine it. Now, this one is another common mistake, right? Exponent is the same. Coefficient is different. Great, wonderful. The base is different. Yes, they're both variable, but they're different variable. If this one happened to be an x and this one happens to be a y, then yes, you can combine it. However, since this is an x and this is a y and they're two different things, even if they have the same exponent, you cannot combine them in any way. You cannot add or subtract the exponent, okay? And you really can't do much with this at all. This is basically as simplified as it can get, right? This one you can solve, this one you cannot. All right, so there you have it. That is adding and subtracting exponent. Once again, it's not that complicated. You're worried about the coefficient only if the different expression meets two criteria. Base must be the same, exponent must be the same. Coefficient can be different, that's entirely fine. If those two requirements are there, all you have to do is add the coefficient or subtract the coefficient based on the problem itself. If there is not a coefficient in front of either the variable or the exponent expression, right, imagine an invisible one and then complete it accordingly. Other than that, be very careful of the wording of the problem. Simplify, solve, evaluate. I don't like the way they intermingle and mix those up a lot, right? This example, as I showed you guys, you can solve it, you can find an answer. You cannot add or subtract the exponent or simplify or combine like terms in any real way. All right, so there you have it. Hopefully I didn't make it any more confusing than it really needed to be. Just be very careful of how they phrase the problem, and outside of that, just add and subtract and go nuts with it. All right, thank you for watching. If you haven't already, please like, comment, and subscribe. I will see you in the next video.